Hey guys, so today we'll be learning something called the quadratic function and the quadratic equation. We'll get into the functional parts as well as factorization, and if we have time, we can also include the quadratic formula. So let's start with the quadratic equation. So let's just say that the basic or the standard form of a quadratic equation is ax squared plus bx plus c. And in the test or somewhere, you'll see equals 0, and you're supposed to factor out or perform other means in order to find the x values. So there are actually three ways that you can use the quadratic equation to find the x values. So the first way is factorization. Second way is the quadratic formula. And then the final way, which I don't really recommend, is called functioning using your calculator. Okay, so let's first start out with a problem. So consider x squared plus 2x plus 1. Now, what you're trying to do is to find two numbers. When they're multiplied, make 1, and two numbers, when they're added, make 2. So this will be a and b. A plus b is 2, and ab is equal to 1. So let's just think of two numbers. And those two numbers can be the same, which it is in this case. So if we just put a 0 right here, the answer, hopefully you realized it, but the answer is 1. So the answer to this function, it can be factored this way. And you would put a squared because this is a squared. So, and the answer to this would be x would equal to -1. So that's basically a good introduction to the quadratic equation. And there are some basic formulas that I want you to memorize if you want to be good at math, which is a plus b squared is equal to a squared plus 2ab plus b squared. And same goes for a minus b squared, which is equal to a squared minus 2ab plus b squared. So if you see a minus, it's a minus. So make sure you remember that. And when you see a plus, it's a plus. Those are the only things that you have to remember. And if you have learned of the FOIL method, which is a plus b, and let's just say a minus b. So this is not, you can find it using the FOIL method, but this is actually equal to a squared minus b squared. I just memorized it because it is very easy to remember. Just look for the negative sign here, and the b values are the same. So an example of this would be x minus 2, right? X plus 2, right? Then this would be equal to x squared minus 4. So that's a very simple yet easy to remember sort of thing. So I hope this made sense so far. This is very important for later steps in factorization. Okay, so let's move on to the next part, which is factoring not this type of scenario, but something more complex. So let's just pretend like I am making a question for you guys. So for 5x, disregard that. Yeah, actually 5x plus 4. So I'll give you, so if you're watching this on YouTube, you can pause the video and think about some possible solutions. It'll be good if you can find a possible solution. If you haven't learned quadratic equations yet, you're on the ride, so you're on the right place. Again, think two numbers, a plus b, ab, right, times. Okay, so if you have thought of that, then you'll probably realize that the answer to this would be x plus 4, x plus 1. Okay, So the answer to this would be x equals -4 or -1. So if you see a plus sign, that means it's a negative. If it's a negative sign, that means it's a positive, and we'll get into more examples like that. Okay, so that's pretty much it for quadratic equations. If you know how to factorize these, actually, let me give you a more, a kind of a different question. So perhaps let's say x squared minus 5x plus 4. So it's a very similar question, as you can see. And the only difference here is that there's a negative sign in here. And same logic applies here, x plus a plus b, and for -5, and a times b for 4. So you can pause the video, but I'm just going to write the answer down for you guys. So the answer to the question would be x -4, and then x minus 1 equals 0. So the answer to this would be x is equal to 4 or 1. Okay, so I hope that makes sense. And the quadratic formula. So there will be times in which you wouldn't be able to solve the quadratic equation through factorization. And in that case, you would use the quadratic formula. So an easy way to remember this, it took me a while to memorize this actually, but just try to repeat it to yourself or something. B squared minus 4ac over 2a is equal to x. And as you can see, you know how there's a plus and a minus. It suggests that there can be two solutions to the x. And there is also an even simpler way of the quadratic formula, but in my opinion, it's quite a waste of time to memorize all that, because at the end of the day, you won't remember it like me, and I just stick with the original quadratic formula. If you're an IB student, you would get the quadratic formula in your formula booklet, but for the people who are taking IM1 and IM2, make sure you remember this in your head, because you won't get to see this anywhere in your book. Okay, so an example, well, obviously I'll give you an example of how to use this. Let's just say that, and oh, by the way, the A, C, B, all these values come out from the standardization of x squared plus bx plus c. So that's where these B's and A's and C's are coming from. Okay. All right, so an example would be of this would be x squared plus, I'm going to just write a random thing. Okay. So you can try many ways, but this this equation is not factorizable. So in this case, you have to use the quadratic formula. So my b value here is 5. Let's just label these values out here. So a would be 1 in this case, b would be -5, or b would be 5. That's my bad. And c here would be 8. Okay. So -5 plus or minus the square root of 25. I'm going to just do these in my head very quickly, times 1 times c, which is equal to 8 over 2a, so it's 2. I know this is not a very pretty problem because I just came up with it in my head, but in the test, usually these values can be canceled out. So they'll probably give you a value, say like, say 4, then it will be divisible by 2. So the answer will come out in a more prettier way. But unfortunately, I didn't really have the time to think about this. So that's pretty much it. And if you just simplify this further, you would be left with -5 plus or minus the square root of minus 32. So that would be -7 over 2. So obviously, you can't have a square root. You can have a negative symbol inside a square root. So that will be, it will be turned into something more related to complex numbers. But I don't want to get into that because it's going to be way too complicated. But let's just put it that way. So the answer to this would actually be just root 7I plus minus -5/2. And then, yeah, that's equal to x. So I know this is not a very pretty problem, but hopefully you guys can understand what's going on and apply the quadratic formula into situations that is not factorizable. Okay, so let's move on to quadratic functions. So say we have a function a squared plus bx plus c, right? It's equal to fx. Okay, so this is the standard form of the quadratic function. And what information can we get out of this standard form? Well, first of all, the c value here, this is the y-intercept. The a value, you can call this the slope of the quadratic function. I don't really have a word for it. And don't worry about the b, because b doesn't really give you anything that you can use straight away. So if you're asked to function this, if you're asked to graph this in a xy plane or xy plane, you would look out for the y-axis, so the y-intercept, and then also the slope of the quadratic function. But normally, I would actually factorize this, and since I don't, these are not real numbers, it's really hard to explain it. So let me just use real numbers to explain this. So for example, like the example we used last time, which is x squared plus 5x plus 4, right, is equal to y. Y is equal to fx, so know about that. Okay, so let's just say 4, right? We know that this function will move on to 4, and we can also factor this out into x plus 1, x minus plus 4, right? And we can just say that when it passes through 0, we know that the x values are -1 and -4. So -1 will be around here, -4 will be about here. So we can get an idea of how, oh, that's a very bad drawing. Something close to this, even though it's a very, very bad drawing, and I apologize for my very bad drawing. Let me just delete this part. Pretend like you guys can see that. Okay. And you may notice something interesting here, which is this part. This is known as the vertex of the quadratic function. And how do you find the vertex? That's a very good question. And I told you one way of functioning this. So this here, we just put this as y as well. This is known as the vertex form of the quadratic function. This is known as the standard form. So let me just write it here so that you can write your notes down or something. Standard form. This is the vertex form. My bad. This is the factorized form. And finally, we have another way to express a quadratic function, which is fx equals ax minus p squared plus q. And here, q represents the y of the vertex, and p represents the x of the vertex. So if we can convert this, the standard form, into the vertex form, we can figure out the vertex, the coordinates of the vertex. And these are many ways that you can express the quadratic function so that it is easier to graph it out. So sometimes the function is not factorizable. In that case, you have to use the vertex form. And if you are a smart student or something, or you like math, then you might realize, or you may have realized that this the quadratic formula that we discussed above derives from, or was derived from, the vertex. So if we just simplify this, put a square root around it, then you would get the exact same quadratic formula. Okay, and another thing to point out here is that the A in the standard form is equal to the A in the vertex form. All right, so let's just use the same example over and over again. So let's just move this, x squared plus 5x plus 4, right? Equals y. Let's move, let's change that to the vertex form. And how would you do this? Well, first of all, I would personally do it like this. So x squared plus 5x, and this is a pretty bad example because what you have to do is you have to divide the b value by 2. So 5 divided by 2, that's 2.5. 2.5 times 2.5, or 2.5 squared, that is equal to 6.25, right? Okay, so since you added a 6.25, you have to subtract a 6.25, and this should be automatic because you in mathematics, you can't add something without adding it to the other side, or you can add something and subtract something at the same time. So that's legal. Okay, and then the 4 is just there. So if we simplify this, this will equate to x plus 2.5x, 2.5 squared, right? And this basically, it's this chunk. It changed into here. And then 6.25 plus 4, that is equal to negative 2.25, right? And this part moved into here. Okay, and notice how we didn't have an a value here, so it was pretty easy. We can now, since we figured out this, we now know the vertex, the coordinates of the vertex, which is negative 2.5, comma negative 2.25. And you might wonder why this is negative. Well, here p is negative, and there's a negative sign in front of p, and here is positive. So that means we have to pretend that there's a negative and a negative of 2.5, which suggests that the x coordinate was negative 2.5. And the y coordinate here, which is negative 2.25, here q is positive. Q, there's just a plus on a q, so the whole thing is just negative 2.25. Hopefully that makes sense. If you have any questions, by the way, just write them down on the YouTube comment section, and I'll be glad to help you out later on. Okay, so that was the vertex form. Now, this was a very simple example, and I know I explained it very quickly, and hopefully you guys understood everything that I said so far. But let's move on to a more harder example. And let's start out with a harder factorizing example. So I'll start out with the FOIL method. So let's just say that 2x plus 1 times x plus 5, right? Now this will equate to 2x squared, right? Plus 10x plus x plus 5. Usually I would do this in my head and just say 11x, but for the sake of the description, I'll just write it like this. 2x squared plus 11x, right? Plus 5. Okay. So now let's just say that we have to convert this into this form. And I learned math from a lot of teachers in AAS, and so far I was not impressed with their way of teaching. It was just too inefficient, such a waste of time. So I'm not saying that their method is bad, it's just time consuming, and there are better ways to do this. So my way, I call it the Korean way. You can call it the whatever way you want, but usually teachers will ask you to multiply 2 by 5 and then just, like do some algebra, do some weird stuff, and then get your final answer. Well, I don't recommend that way. So remember how this equation right here stemmed from the 2 binomials here? Okay, so Same way as previously, pretend like we have two numbers. And think of this, think of the two binomials as something like ax plus b times by c x plus d, okay? So here, 2 will be a times c, and 5 would be d times d, okay? So let me show you the way how I do it. So 2 and 1. 5 and 1. You see where this is coming from? And you see how this can be b, this can be d. All you want to do is make sure that the cross multiplication of two numbers and the addition. So I know that sounded very complicated. Let me repeat myself. So cross multiplication, 1 times 1 plus 2 times 5, which is 10. This should be equal to this number right here in the middle. This is equal to 11. And what this suggests is that basically we don't have an x here because for the sake of complexity, but just imagine that there's an x here, which will lead to 2x plus 1, right? And you see how this is in order, 2, 2, and there should be a little x here, 1, and then if you don't see anything, no negative sign, it's always a positive, and then 1, so that just means x, right? There's also an x here, but I just don't write x because it's kind of obvious. And then plus 5, right? So we're back, we're back to where we started, which is here, right? It's the same thing. And hopefully this made sense. Okay, where was I? So yeah, so I was trying to explain functions, right? Yeah. Okay, so this is the harder example of factorization. And you can use factorization in quadratic equations, in solving quadratic equations, or even graphing quadratic functions. So call this f of x. The x coordinates will be when here, let me just write it as a side note. When y is 0, x coordinates would be negative this, comma, negative 5, okay? Because, so you might wonder where this came from, where the negative 0.5 came from. It's equal to 2x plus 1, right, equal to 0. Then 2x would be equal to negative 1, therefore x is equal to negative 1 over 2. Okay, let's just delete this because it's a waste of space, but hopefully that makes sense, right? All right, and then finally the vertex form, right? Okay, so 2x squared plus 11x, yeah, plus 11x plus 5. Okay. So you want to change this into, and this is with fx, by the way. You want to change this into the vertex form, which is x minus p squared plus q. Just remind yourself that this is the vertex form. This is the vertex form. Okay. So a in this case, remember how I said a in the standard form and a in the vertex form is the same. Therefore, I would factor out a. Okay. Then x squared plus 5.5x, because 2 times 5.5 is 11. And then I would actually leave the c by alone, just plus c, because the c, it's a constant. You can always, add it with another integer or something. So I would first stick with this, and right, this is the same thing, and then move on. 2 times x squared plus 5.5x. And remember how I said divide this into divided by 2. So 5.5 divided by 2. I'm just doing it in the calculator at the same time. So that's 2.75x, or 2.75, and then find the square root of that, and that is equal to 7.5625. So just to remind how I got this number, basically I divided 5.5 into 2, and the square root of that. We got this. Also, in my beginning explanation, I should have also mentioned that. So, where was I? Yeah, so 5, divide this by 2. So 5 divided by 2, square that, you get 2.25. Okay. So I know this is very complicated. This should be pretty hard if this is your first time learning quadratic equations. 2.2. Remember how I said if you add something, you also have to subtract it in math, right? Close the brackets down, and then there should be a plus 5. Just plus 5 just remain where it was. Okay, and 2, and you want to get this out, this thing out. You want to get it out of the bracket, and what you would do is multiply this by 2. Which now you get 15.125. So this would be equal to negative x squared plus 5.5x plus 7.5625 negative 15.125 plus 5. Okay. And here's the magic part. Very satisfying. Watch this. Plus 2.75 x squared and negative 10.125. There it is. So you basically wanted to make this. And remember how I said a plus b squared was equal to a squared plus 2ab plus b squared. Basically, you could have wondered why you're dividing by 2. This is where the 2 came from. And basically a here, as you can see, there a is 1 in this case. So therefore, we just wanted to find the b squared part. Okay. All right. That was the hard part. Okay. So that was it, Hopefully that gave you a brief introduction into the quadratic function, quadratic equations, and the quadratic formula. I know we covered a lot of things in a short amount of time, but hopefully it makes sense to you guys. And if you have any questions, make sure you let me know in the comment section below. All right, thank you guys for watching, and I'll see you next time in the next video.